Hi Year 8s, let's look at Chapter 5a, the language of algebra. By the end of the lesson, you should be able to identify algebraic vocabulary and write algebraic expressions. Let's look at the algebraic expression on the top right-hand corner. 5a plus 7b plus c minus 3ab plus 6. That's quite a large, long algebraic expression. You might have seen smaller ones, shorter ones last year. But the whole expression itself is kind of like a sentence, and it's made up of different fractions. So let's look at the different types of vocab or the different types of letters that you might find in an algebraic expression or sentence. The first one is a pronumeral. Pronumerals are a variable value that's represented by a letter. So it could be any letter. The examples in this expression here is A, B, C, and AB. 6 does not have a pronumeral. Represented by a letter, for example, A, B, C, K, X. Okay, you might have different ones in the textbook, but they're all pronumerals, and that means that their values can change or they are varied. So different pronumerals have different values. For example, A cannot equal B, which cannot equal C, which cannot equal X, and cannot equal K. So the value of A might be 3. B we know is not going to be equal to 3 because that's the value of A. So B might be a completely different value like -8, for instance. Coefficients tells how many of a pronumeral are in the equation, i.e. the number to the immediate left of the pronumeral. For example, this example here is 3x plus 2k. And that really means that 3x is just x plus x plus x. There's 3 of those x's, and so we condense that down into 3x. Plus 2k's, so that's k plus k. Okay, and when we have anything added to itself, we can just condense that to be 2k, a multiplication of itself. So 3x is really 3 times x, and 2k is really 2 times k. The multiplication symbol can be written as in a normal multiplication operation, which you might see as an x, or it could be written as a dot to avoid confusion. I know that my x's look very much like my multiplication symbols. My x, if you see here, is 2 solid lines crossed, and my pronumeral x, my variable x, is like a backward C and a forward C. So they are different and they mean different things, so don't confuse them. You could write 3x as in 3 times x, or you could write it as in 3.x, and it means exactly the same thing. Over here we have a term. So a term is a part of an expression which includes a pronumeral, a coefficient, a number, a multiplication symbol, and a division symbol. Okay, a constant term contains no pronumerals at all. For example, we've got -6 or +2. Here are some more definitions. A sum. We've looked at sums before in Chapter 1, integers. A sum of the pronumeral A and the pronumeral B, when we were to write that out, it would look like this, A plus B. So that must be an addition. Okay, an addition, sum means addition. Difference means subtraction. So the difference of A and B, pronumeral A and pronumeral B, is A minus B. Product means multiplication. The product of A, pronumeral A, and pronumeral B is A times B, or A dot B, just like these examples here. The quotient of A, pronumeral A, and pronumeral B is A divided by B. So the quotient means it's a division symbol. The square. The square of pronumeral A is written like this, A to the power of 2, or just A times A. And the cube of the pronumeral A is A to the power of 3, or A times A times A. Let's look at a few questions. Question number 1, how many terms in the above expression? So if we look at this expression up here, how many terms can you identify? Well, remember, a term is a part of an expression which includes both a pronumeral, coefficient, number, multiplication symbol, or a division symbol. So the number of terms that we have here we have 5a, that's one term. Now I know it's a positive because there's no negative in front of that 5a. If there was a negative, I would say the term was negative 5a. There isn't a negative symbol, so it's a positive 5a. The second term is positive 7b. That's two terms. My third term is positive c. Fourth term is negative 3ab. And my last term is positive 6. So how many terms in the above expression? There are 5 terms altogether. What is the coefficient of a, b, c, and ab? Remember, the coefficient tells how many of a pronumeral are in the equation, and it's the number to the immediate left of the pronumeral. So the pronumeral a is this one here. That's the pronumeral, and the coefficient to the left of that is 5. It really means 5 a's. A plus A plus A plus A plus A, 5 of them. So the coefficient of the pronumeral is 5. The coefficient of the pronumeral B, we say, is positive 7 or just 7. What's the coefficient of C? Here, there is no number in front of the pronumeral, okay? But the fact that it's been included in the expression at all means that there's at least one C there, and we know it's a positive one. So we can put that imaginary 1. There's one C. And the combination of these two pronumerals still is one term. You don't count it as 2 terms, it's still one term. But that means 3 times A times B, okay? So the coefficient of the pronumeral AB is negative 3. And what is the constant term in this whole algebraic expression? The only one without a pronumeral is the number positive 6. So our constant term is positive 6.